Hello, Accelerated Math 7-8 students. We are working in Module 12, and this is Lesson 4, and it is called Sequencing, Translations, Reflections, and Rotations. Sequencing, Translations, Reflections, and Rotations. So take a look at this really quickly. Here are our notes for today. As you can see, they're pretty short. Okay. So the title again, Sequencing, Translations, Reflections, and Rotations. The goal. Today we will learn about the sequences of transformations. The question that I want you to be thinking about in this lesson is, does the order matter when transforming figures? Okay. So we're going to check this out. What we are supposed to do with this little check this out activity is the colored arrows are your vectors. So you need a transparency, and you need to check and see what's going to happen when you do this work. So if I put my transparency on here, okay, this is going to be fun because I'm going to have to transfer it to a piece of paper. So we have N, which is there. We have a heart, which is there. And we have an angle, XYZ. And I know that the angle measure, oh, it didn't show up. It's supposed to be 19 degrees. And this is supposed to be 7 units long. Okay? And, ooh, don't do that. Don't do that. Don't do that. Don't do that. Go back down. Okay. This is hard writing on an iPad and not expecting it to move. All right, so I have a vector that goes from here to here, and a vector that goes from here to here. Okay. I'm going to undo that. Back up, back up, back up. Okay, I don't need that. Okay, so here's what we have, and it says use the vectors to transform the three figures above. Okay, so I'm going to put this on a piece of paper, because this is where it was before. Let me put a before image underneath it so that we have a starting spot. So we have a heart here, we have N here, and we have our angle right here. And I'm sorry, this is going to look not as fabulous as it normally does. All right, so there is our stuff, kind of. Okay, good enough. All right, and our vector that we have, I've got to put my vectors on here. Our vector goes from here to here, and then it goes from there to there, right? Okay, so what we have to do is we're going to take our first movement, and we're going to go over here, like that. So that's where our image sits, because this was our pre-image under there. So this is our image, and we're going to call it our image prime. So I have to draw the new one, so Z prime, Y prime, X prime. Our new location of our heart is here, so this would be H prime, and our new dot would be here, so this would be N prime. So that's the new location of the first vector. Now I have to take, oops, I've got to get my new vector on there. So this is my new vector, right? Okay. And now I have to take my second vector and go up. So here's where it now fits. So N prime prime, heart prime prime, and angle prime prime. So Z prime prime, Y prime prime, X prime prime. So now let's look at what happens. First question, did my angle measures change? The answer is no, because it's been preserved. Did my segment length change? No, it's preserved. Okay? What is the only thing that happened when we followed these two vectors right here? Okay? The only thing that happened was our location changed. So it says on our notes, use the vectors to transform the three figures above. Using precise mathematical language, describe what you transformed. Okay? What do you know about the side lengths and the angle measures? How do you get the image back to its original position? Okay, so let's talk about what happened first. So it says use precise language. So we're going to say I transformed. Actually, it's not transformed. It's translated because I used vectors. I translated the angle, XYZ, the heart, and point P, point N, sorry, along the red vector and the blue vector, because they were red and blue. Okay, so I used precise mathematical language to describe what I did. The next question says, what do you know about the side lengths? So what do we know about the side lengths? The side lengths, you have to write this, the side lengths were preserved. Okay, what do I know about the angle measures? The angle measures were preserved. Okay, and now the last question says, how do you get the image back to its original position? So who can tell me? How do we get this back to here and this one back to here? So how do we take the image back to its pre-image and then take that image back to its pre-image? What do we do? And if you're saying that you follow the vector backwards, then you are correct. So this is what we're talking about in our lesson today. Some of you are going, Mrs. Nelson, that's a lot of writing. Yes, it is, but we're trying to teach you how to be precise. And sequencing does matter, because if you don't go in the correct order, so if we did the red vector first, so if we went and took what we had, okay, so this is where we ended up. It's clear up here. So if we take the red vector first, so we went, and then we went down, do we end up in the same spot? Look at my transparency. Are you in the same spot? And the answer is no, we're off. So the whole point of this question is, does order matter? Yes, because you have to take the blue vector first, right? That puts us to here, which is where we went to first, and then back to the red, and you end up in the right spot. Okay? So the question where it says, does the sequence, does the order matter when transforming figures? And the answer is yes, because if you don't go in the correct sequence, then you won't end up back where you started from. Okay? Again, geometry is hands-on. It's a lot of practice. This is what you're going to be doing in this lesson today, and I think you're going to like it. All right, that's all I have for you today. I'll see you tomorrow. Bye.